Okay, last time I went through this is my second time. It went a little long and we didn't have enough memory. So I'm going to try to go through this a little faster, and if I go too fast, just hit pause. Okay, it's a lunar eclipse. It's when the moon appears darkened as it passes through the Earth's shadow. It's really cool. This doesn't happen very often. Let's watch it again. So there's a lunar eclipse. And here is a solar eclipse. It's when the moon shadow passes over the Earth. Let's watch that again. Okay, it's an ellipse. It's like a flattened circle. It's the shape of our orbit around the sun. An ellipse. Lightyear. The closest star to our sun, our solar system, is 4 light years away. That means the light from that star left 4 years ago when you see it. By the time it reaches your eye, it left 4 years ago. So every time you look at a star or anything in the sky, it took time for that light to get to you. Light travels at 186,000 miles per second. So it takes time. It takes about 7 to 8 minutes for sunlight to get to the Earth. Okay, space distances are so big. So sometimes we take something like 93 million miles and we reduce it to something called an astronomical unit. So an astronomical unit is 93 million miles. Oh, here's a great video about rotation. And I'm going to move it up a little faster. Here's rotation of the Earth. It's the spinning. Lots of people get rotation and orbiting mixed up. So it's the spinning. It causes the cycles of day and night. Oh, solstice and equinox. This is a great one. Okay. As we all know, it takes 365 days for the Earth to go around the sun. In different parts of the year, we have different amounts of daylight. On the winter solstice, we have the least amount of daylight. It's December 21st. And as we usually notice, when we leave school in December, it's really dark by 4 and 5 o'clock. The opposite end, so 6 months, when we're halfway around from here, in 6 months, we have a really long day. The axis is pointing here. And northern hemisphere where we live gets more daylight. So this is the longest amount of daylight we get right there. Now these two, we get the same amount. We get 12 hours of darkness and 12 hours of light. And as Paul pointed out, this is 3 months, this is 3 months, this is 3 months, this is 3 months, and the whole thing is 12 months. Jack made this awesome thing about orbiting. He has several of the planets orbiting the sun. There's these great things about videos about meteors. I'm going to turn these down. And this is a time lapse. And it just, a meteor shower, they look like shooting stars to us. But sometimes they're the size of a grain of sand. But they hit the atmosphere and they're so hot that they burn up. And they look like shooting stars. There's one. But when a shooting star or a meteor hits the ground, or what crashes through this guy's house, then you get a meteorite.
Crashed right through their roof. Larry Beck said he thought it was just a rock dropped by a plane on Friday night.
But NBC Connecticut was the only station there when scientists confirmed otherwise. We have live team coverage beginning with Jeff Zapperstone in Wolcott. Jeff.
So this guy's going to point out a hole in the roof.
Larry was sitting on Friday night. He was just watching television. Across the room, that's where he heard the loud bang. And this right here, you can see the ceiling damage. That's where the meteorite came through the roof. He says it's something.
Otherwise, we have live team coverage.
There's a roof. He went through his roof. Okay, this is interesting.
We're going to go ahead and switch gears and go from Earth.
Here's an asteroid.
So we don't have to go very far. There's an asteroid
that's going to pass here.
Passing very, very close to Earth. How about
So that asteroid does not come within the Earth's atmosphere, so we didn't have to even worry about. But the thing that people talk about are called near-Earth asteroids, and this would be called a near-Earth asteroid. Okay, we got some animation. Asteroids are in space, big chunks of rock. A meteor enters the Earth's atmosphere and dissolves. A meteorite actually hits the ground. Oh, this one's great. Here's the North Star. Here's the Big Dipper. We can make it rotate. And what we did here is show that the Earth's axis and the North Pole point straight at this. That's why it rotates. Let's watch it again. That's why it does that. And let's see if we have enough space for it this time. Good luck.